Hey guys, hopefully you enjoyed your long weekend. I just wanted to post a short video going over what the two pieces of work you're supposed to get done for me last week: our intro to algebra, combining like terms, and then part one of solving equations. We're moving on to part two and part three this week, so I wanted to make this video going over what we've done so far, so what we're doing next will make more sense for you. So give it a watch, and any questions at the end, please let me know. Okay, I'm here to help any way that I can. So in terms of combining like terms like we have in this booklet here, it's exactly what it sounds like. We're taking things that are similar and we're adding them together to make the expression of the equation simplified. It's the easiest of us to understand. So for practice example 1, 4x squared plus 8 minus 5x plus 2x squared. The 2x squared and the 4x squared are like terms because they're both have a base of x squared. The 5x is different from x squared because it's not squared, it's just x, right? And then 8 is by itself because there's no x at all. It's just a whole separate thing. So the first step I always do is put them by each other. So instead of having it like this, separate, I would put 4x squared plus 2x squared next to each other, and then minus 5x plus 8, and then 4x squared plus 2x squared, that's 6x squared, right? Minus 5x plus 8. You can add the numbers without having to change the base, right? So 4x squared plus 2x squared is the same as 4 plus 2. Just don't forget to add the x squared to it at the end, right? Example 2, I did the same thing. Here's our original question. I start by putting the like terms together. So there's only one x squared, so that's by itself. There's 5y and 9y, so I'm going to put those by each other. And then I have minus 13 and minus 2. Those are similar. Those are by each other, right? If they're in the same color, they're the same base. They're the same like term, right? How do I simplify that? I can't simplify x squared any further than it already is. That's by itself. What's plus 5 plus 9? 5 plus 9 is 14, right? So plus 14y. What's minus 13 minus 2? So negative 13 subtract 2 is negative 15 or minus 15. It's not minus 11. Yes, 13 minus 2 is 11, and that's what a lot of you guys put, but don't think of it that way. Think of it as negative 13 minus 2, which is negative 15, right? That sign in front of the numbers in algebra, that's part of that number. You can't separate them. Think of it as minus 13. I'm subtracting 13 and then I'm subtracting 2. So I'm actually subtracting 15, not 11, right? So that number, that sign, has to stick with the number when you're simplifying. We're going to go through more examples like that, but that's the major mistake you guys made, was not keeping that negative sign with the number in front of it. So for example 3, first step, I combine the terms together or put them next to each other that were the same, right? So there's only one x squared, so the 6x squared is by itself here. How many y's are there? There's a plus 4y and then a plus y. So I put those together. There's a minus 10, that's it, together. Then minus 8x minus 3x together. How do I simplify that? We'll just can't simplify 6x squared. What's plus 4 plus 1, right? That's plus 5y minus 10. I can't simplify that any more than it already is. And then what's negative 8 subtract 3? That's minus 11 or negative 11. It's not minus 5x. 8 minus 3 does equal 5, but like I just said, we have to keep that negative number attached to the 8. So it would be minus 11x, okay? Same as this one. Put the same terms together, so it makes it a little easier for us. 9x squared, can't simplify that. What's plus 7 minus 10? That's minus 3, right? So minus 3x. What's minus 4y? Can't simplify that. Can't simplify plus 8. So that's it in its simplest form. That's where we're combining them. Same with this, right? Put the x's together. Put the y's together. Put the regular numbers together. What's 5 plus 2? That's 7x. What's positive 7 subtract 17? That's negative 10. So 7x minus 10y. And what's negative 4 plus 11? That's plus 7, right? So we're not going to subtract 4 plus 11 or 15. That's not right. What we're going to do is we're going to add 7 because negative 4 plus 11 is 7, right? We're subtracting 4, then adding 11. So we're actually adding 7. We're not going to subtract 15. I get why you would make that mistake. I made that mistake when I was first learning this too. But just remember to keep that sign attached to it. All right, makes a big difference. Same with this one, right? Combine them together. Simplify. Minus 3, minus 8, right? Negative 3 minus 8, negative 11x. And you can't simplify plus 2y plus 4. Those are just there. Put the like terms next to each other. It makes it easier to simplify. X squared plus 3x squared is 4x squared. Plus 7 minus 4, that's plus 3, right? Plus 1 plus 3y, that's plus 4y. And then minus 2 minus 6. So negative 2 minus 6, that's minus 8. Not minus negative 4 or plus 4, whatever you think you would put. Remember to keep that negative sign attached. Negative 2 minus 6 is negative 8. All right. Last one. Put them by each other, same as every example, and just simplify. Negative 4x minus 6. So negative 4 minus 6, that's negative 10x, right? It's not going to be negative 2x. It's negative 10 because that negative sign, you have to keep it attached. Negative 10x squared plus 5 plus 3. So 5 plus 3 is plus 8y. Minus 9 plus 12. So what's negative 9 plus 12? That's plus 3x. And then plus 10 minus 1. That's plus 9. So the biggest key is don't forget that sign attached to the front. Keep it there. Step 1, put all the like terms next to each other so it's easier to simplify them. Step 2, just simplify, right? Pretty simple as long as you remember not to forget about that sign in front of the numbers. Okay, any questions about this, please let me know. Next, you had part 1 of solving equations. So we're going to go over this together using the balance method. So if you remember the balance method, that hinged on what you do to one side of the equal sign, you have to do to the other side as well, with the whole goal being to get the unknown variable, or x in most examples, by itself on one side of the equal sign. So for example, x plus 9 equals 33. What's stopping x from being by itself on the left side of the equal sign? We're adding 9 to it. So if we want to get rid of that add 9, we have to do the opposite of adding 9, which is subtracting 9. And if we do that to one side of the equal sign, we have to do it to the other, or else they're not going to be equal anymore, right? So x plus 9 minus 9 is the same thing as just x, because the plus 9 minus 9 cancel out. And then we do 33 minus 9, because we had to do it to both sides. X equals 33 minus 9, or you could put x equals 24. We can check our answers, which is great with algebra, see if we're right. We put 24 in for x. Is 24 plus 9 33? Yep, it is, so we know we're right. Our answer is always going to look like that. X equals a number, or y equals a number, whatever variable we're working with. All right. Question 2, x minus 8 equals 31. What's stopping x from being by itself? Well, we're subtracting 8. What's opposite of subtracting 8? Adding 8. We're going to do that to both sides. Minus 8 and the plus 8 cancel out, so we just have x. And then we have 31 plus 8. 31 plus 8 equals 39. So our answer is x equals 39. Are we right? Well, 39 minus 8 equals 31. Yes, we're right. Example C. 3x equals 36. Is x by itself? No, it's being multiplied by 3. So to get it by itself, we have to do the opposite of that, which is divide by 3. Do that to one side, we have to do to the other as well. So 3x divided by 3, that just equals x, because the times 3 and divided by 3 cancel out. And that equals 36 divided by 3. 36 divided by 3 equals 12. x equals 12. Are we right? We can put 12 in for x and c. 3 times 12 is 36. Yes, we're right. D, I'm not going to skip over that one. It's pretty easy, but we're adding 91, so we have to do the opposite or subtract 91. So x would equal 123, subtract 91. Whatever that answer is, that's what x equals, right? Just do the opposite of what's happening to get it by itself. Same with example E. I don't want to keep doing all these easy ones, but x minus 32 equals 95. What are we doing to x? We're subtracting 32. So we have to do the opposite to get it by itself, or add 32. So if we're adding 32, the plus 32 and the minus 32, those cancel out to leave x by itself. And then we got to do 95 plus 32. We got to do it the other side as well, right? Do that math. X equals 127. We can print and see if our answer is right. 127 minus 32 equals 95. Yes, we're right. 4x equals 96. What are we doing next? Timesing it by 4. How do we get it by itself? Divide by 4. So x equals 96 divided by 4. X equals 24. Let's see if we're right. 24 times 4 equals 96. Yes, we're right. And the same thing for the last two examples here, right? I don't want to keep repeating myself, but negative 2x equals minus 70 or negative 70. What are we doing to x? We're multiplying it by negative 2. How do we get it by itself? We have to divide it by negative 2. And if we do that to the one side of the equal sign, we have to do it to the other. So x equals negative 70 divided by minus 2. If you guys did your integer thing on Knowledge Hook, you would know that a negative number divided by a negative number equals a positive number. If you didn't do it, you could use your calculator and it would give you that same answer. But negative 70 divided by negative 2 equals positive 35. So x equals 35. See if we're right. Minus 2 times 35 equals negative 70. Yes, we're right. That's the answer. Okay, that's part one. One step, simple enough. Where you're going to be working on for me the next couple days is part 2, where we're combining steps together. So I'm going to do one example or two examples here to show you how to do it, and then you're going to have to try it by yourself. All right? Example I here. 3x plus 7 equals 34. So what are we doing to x? We're timesing it by 3 and we're adding 7. Our goal is still to get it by itself on one side of the equal sign. So we can start by getting rid of this plus 7. How do we do that? We subtract 7 from both sides, right? So let's go 3x equals 34, subtract 7. Or you could simplify 34 minus 7 to 27, right? 3x equals 27. Now what's keeping x from being by itself? Or timesing it by 3. What's the opposite of that? Dividing by 3. So we just got to divide both sides by 3. X equals 27 divided by 3. X equals 9. Let's see if we're right. Let's put 9 in for x. 3 times 9 equals 27, plus 7 equals 34. Yep, that statement's true if x equals 9. One more example. 2x minus 13 equals 53. What's stopping x from being by itself? Well, we're timesing it by 2 and subtracting 13. So let's start by getting rid of that minus 13 by adding 13 to both sides. So 2x equals 53 plus 13. Or you could say 2x equals 63, right? Now what's stopping x from being by itself? Well, we're timesing by 2. So we have to divide by 2 to get it by itself. X equals 63 divided by 2. And if you do that math, x equals 31.5, I believe. Does that make sense? Oh, I got the wrong answer there. Sorry. It's 66, not 63. 66. 66 divided by 2 equals 33.